you can actively bring your cerebrospinal fluid up into your third ventricle and essentially create a rhythmic pulsation in the middle of your brain with your breath. Study at UCLA, where I got a degree in molecular, cellular, and developmental biology. That took me through studies of genetics, molecular biology, developmental biology. I did a MD PhD at Harvard Medical School. I chose to do a PhD in the cerebrospinal fluid. Then I started working mostly with people in trying to help them function better. One of the specialties is called physical medicine and rehabilitation, helping people to improve their functional capacity and to decrease sufferings. Well, the cerebrospinal fluid, just purely based on the molecules that it has in it, is a less differentiated, less condensed, less solid form of our fascia, of the connective tissue that makes up our entire body, that is present throughout our entire body. Because it's a liquid connective tissue that is present in the middle of our spine, in the middle of our brain, bathing the outside of our brain. And as the fluid condenses and becomes more dense, it then forms the connective tissues that you would see in between the cells. And so that was really surprising. The other surprising thing for me is how much it changed during embryologic development. We didn't really think that the fluid provided any clues or any instructions to the developing brain. But now we see that it's actually very important, providing neurogenesis, or the making of new neurons, as well as differentiation. If you have a stem cell, the stem cell when it divides, it needs an instruction. Do I stay a stem cell, or do I differentiate and become a neuron or some sort of differentiated cell? And what we found is that the cerebrospinal fluid, during embryologic development, it's quite dynamic. So there's proteins that increase and decrease. Do we need new neurons as the brain is growing? Do we need to differentiate the neurons? What we found was that the cerebrospinal fluid was actually providing instructional and informational guidance for the developing brain. And that was one of the first time that had ever been instructed as well. And we looked at very specific proteins in the cerebrospinal fluid, growth factors that had a very dynamic display in the fluid itself, that was consistent, reproducible, and that actually had information that the brain was using for development. And there was just a study done, 4 different they called them yogic breathing patterns, and how these breathing patterns moved the cerebrospinal fluid. The question to me is, this is fascinating. I love the fact that we're asking these questions. And now it's, yes, okay, so what do we see? Well, when we inspire, when we have like a strong inspiration, what we're doing is, from any level of our spine, we are bringing cerebrospinal fluid up into our brain. They have specifically looked at this. It goes into the third ventricle. All right, the third ventricle, if you could imagine it as a perfectly midline space, sort of directly behind your brow center. Midline space, and with an inspiration, you're bringing this cerebrospinal fluid up into the middle of your brain. With exhalation, you can actually, they've seen with exhalation that sort of from mid-thoracic level down, you can actually, it pushes the cerebrospinal fluid down towards the sacrum. So we're looking at how breath is actually controlling the movement of the cerebrospinal fluid up and down. As you're speaking, right, just listen to the frequency of the words, because if you're singing, you're activating all the cells, all the fluid, all the connective tissue in your neck. You have cerebrospinal fluid that's coming up the center of your spine. You're going to be affecting that as you hum. You're going to be affecting that fluid. You're going to be sending, I'm sending a vibration. My cells are resonating with that frequency. Now, if you add intention, a mantra, a visualization, directing it, now you're enhancing it. The only thing that can get in the way is ourselves.